Okay, one of the big questions I've been getting has to do with the idea of polarization. Okay, I've also gotten questions about induction and conduction, but I've got other videos on those. So one of the big questions is polarization. And so we're going to use the simulation. That's what the simulation is really good for showing. And so first we'll do a little conduction. And so conduction means charging through contact. And so we're going to use friction. And so we have a rubber balloon and we've got like a wool shirt and wool's just animal hair. So this is the exact same idea as when you rub a comb, which is plastic, uh, which is very similar to rubber, and your hair. Okay. So if we rub these together, that was easy. You'll notice that the balloon has gained excess electrons, but the protons stay where they are, because that's the rule. You can't have the protons moving. If the protons move, then you'd have elements actually becoming different elements because it's the number of protons that defines what is in an element. Okay, so we've basically charged this through conduction, through contact, it has gained or lost electrons. This balloon is very negative now. And if you look at the arm of the sweater, it's very positive. So if I let this go, they are attracted to each other. Okay, this is why stuff sticks to you, especially in the winter. You get that static cling if it comes out of the dryer, all that stuff. But now let's talk about polarization. So if we look at the wall is neutral. It's got the exact same number of protons and electrons. Again, let's make this super negative. Oh, now one thing I gotta say is you can't actually steal all the electrons. Okay, that's never gonna happen. Okay, these are like excess free roaming. We've stolen like one from a periodic valence shell. We're not stealing all of them. So that's going to bother me, so I'm going to just do that again. We'll take a few less. Okay. Now, if I bring it over to this wall is neutral. Again, same number of protons, same number of electrons. But look what happens as I bring the balloon near the wall. Do you see how the charges are moving? So I'm going to steal a few more. Again, I refuse to steal them all because that would never happen. But you can see how the electrons inside the wall are being pushed away. Now, they're not running all the way away, they're just being pushed away because, again, like charges want to repel. So we've got a very negative balloon here, and it's pushing away the negatives in the wall, which means this area right here is actually going to become positive. And this part over here, since it has excess electrons in it jammed right now, is negative. So when you get polarization, you just get a kind of a rearranging of electrons. It's not like they went away. It's not like we got more or we lost any. They're just redistributing themselves so that you have a positive side and you have a negative side. And now that we see this partially positive side, because again, it's not like the whole thing's positive, just this near side is now positive, we have attraction between the very negative balloon and this partially positive side of the wall. We would have repulsion if we brought it to this side, but again, when we're talking about charge polarization, we're just talking about getting a positive side and a negative side by bringing a charged object nearby. All right, so as you can see, as I move it around, the electrons are going to try and move away. So that's why if you rub a balloon on your hair and you stick it on a wall, it stays there because you have this attraction. Now, eventually, some of these electrons will travel to the wall, and some of them will get rubbed off by the air, and so that's why the balloon eventually falls, because these will eventually reach the exact same charge. And once they have the same charges, then they will either not care about each other because they'll both be neutral, or they'll end up hating each other because they'll both be negative in this case. Okay, so that is the big difference. All right, that's the big idea behind charge polarization.